We're talking patterns and linear functions, okay? You know what a pattern is, right? 2, 4, 6, 8, that's a pattern of adding 2 each time. 3, 9, 27, that's a pattern of multiplying by 3 each time, okay? We're looking for those types of patterns in what we do today. Olivia.
I went to my grandpa's house yesterday, and he was watching the Jeopardy, and they talked about that.
Patterns? Linear function.
Yes?
Yeah, they totally did. I got that answer right. It was like the one thing I got right. Yes, they said, oh, man. No, I totally remember that. I was like, Landon, I got one. But, math question. 2 different types of variables that we're going to start with. Shh. It's go time, people. What's a variable? It's the letter, okay? So we are talking about the letters in the problems. Girls. The first type of variable that we're going to talk about is called a dependent variable. Okay, a dependent variable. And here's what it is. A dependent variable changes in response to another variable. It depends on something, right? Like you depend on your parents for food every day, okay? If they don't give you food, that's an issue for you. You depend on them, okay? Yes. Or your guardian. Yeah, but your parents have paid for that, right? Yes. Yeah. Okay, anyway. So the other thing we call this is called an output. In other words, you can put something in and what comes out is your dependent variable. Your output is your y, typically, okay? It's not always, doesn't have to be, but if we're looking at an equation like y equals 2x minus 4, this is your output, right? It depends what we put in for x, what we get for y, okay? The second one is called your independent variable. Why are we not writing? There we go. Explain everything. The independent variable doesn't depend on the other variable. This is also known as the input. So it's what you put into the function. This is typically your x. And it's independent. I can pick any number to plug in for x, and that will tell me what I get for y. Okay, so independent versus dependent. So in this picture right here, which one of those is independent?
X.
The x is the independent. X can do whatever it wants to do. It's independent. You can plug in any value for x. The dependent is the y, okay? Again, this is the input, what you put into the function. This is what you get out of it. Right, I know, that makes sense, but it's not how it works. Okay, so here's where it gets a little tough. You just got to really think about what's going on here and take your time with it, okay? Example 1, it says, what is the relationship between the number of rectangles and the perimeter of the figure they form? What is a perimeter?
Like this.
The distance around, right. It's the value of all the lengths around a figure, okay? So we're going to define our variables. It says, what's the relationship between the number of rectangles? So x is going to be our number of rectangles. Okay, and then our y is the perimeter of the figure. Because the number of rectangles affects the perimeter, right? So the perimeter depends on how many rectangles we have. So x is your independent variable. We can plug in any number of rectangles, and we'll see what perimeter we get out of that, okay? So we're going to do this several ways, sometimes with a table, sometimes with an equation, sometimes with a graph. We're going to do all 3 of those right now. But here's what I want you to see, okay? this is essentially 4 different setups. Right? We have 1 rectangle. The next picture we have 2 rectangles. The next picture we have 3, and then 4. Okay? So that's going to be our values here. 1 rectangle, 2 rectangles, 3 rectangles, and 4 rectangles. What we're trying to figure out is what is the perimeter. Well, in a rectangle, opposite sides are the same. So if this one is 6, so is this one. And if this one is 1, so is that one. So we're saying to find the perimeter of the rectangle, there are 2 1s and there are 2 6s. Okay? That's going to tell me the perimeter. What is that value?
14.
That's 14. 2 plus 12. Okay, so the perimeter of 1 rectangle here is 14. The distance around it. I just went 6 plus 1 plus 6 plus 1. But basically that's 2 1s plus 2 6s. Okay? Okay, now look at the next picture. These lengths are still going to be 1. These lengths are still going to be 6. How many 1s do we have now?
4.
There's 4 1s. So we're going to do a length of 2 here and a length of 2 here. Okay? So this is 2, this is 2 for the side of our figure. So we're going to say we have 2 2s. Right? That's our 4 1s. And we still have the 2 6s. What does that add up to?
16.
16. 4 plus 12. Okay, so that's 16. All right, let's look at the third figure. This is 1, 1, 1, and 1, 1, 1. This is 6, and this is 6. So this length is what? That top length is 3. Okay, so that's 3 on top and 3 on bottom. So we have 2 3s and we have 2 6s for our perimeter. Okay, that adds up to what? 18. That's 6 plus 12, right? So 18. Okay, now the fourth one. Up top here is how long?
4.
4. All 4 1s again. So that's 4 down here. And then our sides are still 6. The sides here didn't change. So we have 2 4s and we have 2 6s. So that means we have 8 plus 12 or 20. Okay, so here's what I want you to see. Because we have to try to come up with an equation for what is happening here. And I feel like typically what we say is, what did you do to this number to get that number? What did you do to this number to get that number? What did you do to this number to get that number? Well, looking at this problem, it's not easy to see it, okay? It's not like, oh, yeah, I just added 13. Well, if you add 13 on the first one, and then you add 13 to the 2, you don't get 16 anymore. So it's not just add 13, okay? We need an equation. We need multiple things done to our x, okay? We said our x is the number of rectangles. So if you look here, let me just highlight something for you. This was 1 rectangle, and we took 2 times 1 down at the bottom. This one was 2 rectangles, and we did 2 times 2 at the bottom. This one was 3 rectangles, and we did 2 times 3 at the bottom. And this one was 4 rectangles, and we did 2 times 4. Okay? Notice this. We added 12 every time. Okay? So, all that to say, our equation is really just saying 2, oops, not with a highlighter. Let's get a pen out. 2 times the number of rectangles, right? 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles. So 2 times the number of rectangles, 2 times x, plus what? What did we add every time? 12. Okay? That is your equation. Okay, now I'm going to show you a fun little trick that will help you get there a little bit quicker if you like this way better. When you have a table like this, your 0 term is always this number. But we didn't have a 0 here, right? But you should see a pattern. Each one of these jumped up by how many? Plus 2, right? Okay, so if we're jumping up by 2, if we went back 1 and made this a 0, what would this number be? 12. Have you seen a 12 recently?
Yes.
Yeah. That was right here, right? So when you set this up, it's usually going to be in slope-intercept form, y equals something times x plus something or minus something, okay? That 12 is your constant. Remember, a constant is the one that doesn't have the variable. This number also shows up somewhere. Do you see a 2 somewhere?
Always like,
2x, right? So if you have a chart like this, if you know the 0 term, which in this case we just had to put the 0 term in, 0 got us 12, that's going to go here. Whatever you jumped up by, as long as we were counting by ones here, which most of the time we are, whatever you jumped up by, that number is going to go there. That will work every time as long as this is going up by your x column, as long as it's going up by ones, okay? And it will be for us, okay? But you can always do it this way too, where you just work out what did I do to find the perimeter, okay? Okay, so if we want to graph this, I'm going to redo our t-chart. You don't need to rewrite this unless yours is as messy as mine, but I just want you to see the numbers easier. So 114, 216, 318, and 420. Okay? If we graph this, you need to make sure that you are being specific with what you're counting by on your axes. Okay, so this one down here, this one is our x, which is our number of triangles. Okay, the vertical is our y, which is our perimeter. In order to fit up to 20, I'm not going to be able to count by ones. What do you want to count by? I'd count by 2s. You don't have to. Everyone's can be different here, okay? Yours might look different than your neighbor's, and that can be okay as long as you're counting consistently by something. So 2, 4, 6, bless you, 8, 10, 12, 14, 16, 18, and 20. Okay. Do you remember how to plot points? Where do I put 114? Over 1, up 14. So that's going to put our point right here. Okay. 216 then, we're going to go over 2, up to 16. 318, what? Oh, in numbering it? Bummer. 318 is going to go there, and 420 is going to go there. Stop it. I was in high school once, too. Every time I say 420, you're looking over there? Mm-hmm. I saw it. Don't act like I didn't see your interaction. Okay, so that's your setup. Questions on that?
I need a ruler.
It's not the easiest, right? It takes a little bit of thought. But if you just slow down and think through what's the process, what's happening here, you can get there. Okay? Okay. You don't have to draw the line in, so you don't need a ruler because you won't have like 1.5 triangles. I said triangles. This is rectangles. Sorry. My bad. Number of rectangles, not triangles. This next one, oh no, one of them in your homework is triangles. Okay, here we go. We are more than halfway. function and linear function. If you watched Jeopardy, this is what they were talking about. For a function, the rule is that each input, each x value, has exactly one y value. So you can't plug x in and get two different numbers for y and call it a function. If you get two different numbers for y, it's not a function, okay? A linear function means the graph is a non-vertical line or a part of one. So a function is going to look, when you graph it, something like this, or maybe it looks like this, but can't be a vertical line, okay? And it can't do something like this, because you'll have two y values for one x value. Okay, so this is not a function. These are functions. Okay, so we're going to graph this function and try to come up with an equation for it. And I feel like this one's going to feel easier because I told you the process already. So we're going to see if you guys can help me come up with this one. Here's what it says. The table shows the relationship between the number of photos, that's our x, okay? So if you want to label it just to help yourself understand, you can do that. X is your number of photos, and the amount of memory, that's your y, in megabytes left on your memory chip, okay? The question is this relationship a linear function? So we're looking for, are we getting a line that is not vertical? Okay, when we graph this. So we want the equation for the line and we want the graph. Now, maybe the graph is the easiest part for you and you're welcome to do that first. If that's helpful for you, that's totally fine. When you graph something like this, notice your y values. You probably don't want to count by hundreds, because when you get to 500, then all of your points are pretty much right next to each other on the graph. You're not going to see a big difference. So what you want to do when you graph these types of numbers, you put a little zigzag down here, which just says, I'm skipping a whole bunch of numbers, okay? So we're going to skip 0 through 500, and we're going to start at 500, okay? But put the zigzag in, and then you can start counting by whatever you want to count by. So if I put a 500 here, I would probably count by twos, just so that, because if I count by ones, I'm going to fall off the top to get to 512. So I would go 500, 502, 504, 506, 508, 510, oops, 512, and I think that's as high as we need to go, right? Yeah. Can you tell me the variable that's going to go down here? No. Photos, right? This one's our pictures. This is our photos. That's our x. What's going to go on the other one then? The amount of memory. Okay. So if you want to just plot those now, let's just do that. So that part is out of the way. So 0, 5, 12. 0 is going to be on the y-axis. So that's going to put me at this point right here. 1 is at 509. So you're actually going to go halfway between the 510 and the 508. Okay. 2 is at 506. And 3 is at 503. Would you draw a line in here?
No.
Why not?
Because
Why don't we need to? Because it depends on the question. It depends on the information. Can you have a fraction of something with this category?
oh no.
No, you have exactly a number of photos, right? You can't have 2.5 pictures. You have 2 pictures or you have 3 pictures. So you don't draw the line in on this one, okay? So that's our setup there. Is this going to be a linear function? Yeah, it makes a straight line, okay? So we can just answer that question. We would say, yes, this is linear, a linear function. Okay, so that's the answer to that part of the question. But we still have to come up with our equation, and that will show you that it's linear also. Okay, can you remember the steps that I told you? What's the constant? What's the number that does not have a variable with it? The what? The b in y equals mx plus b. Yep, it's your standalone, right? Doesn't have a variable. So if you're thinking of the equation in slope-intercept form, y equals mx plus b, this is your constant. What number is that going to be right now? The 512, okay? So this number will always go here. So something plus 512. And we know it's always y equals, so we just need to figure out what goes in that gap. Do you remember how to find that gap?
Well, like, how many is 55?
Right. So what did you have to do to get from 512 to 509? Subtract 3. Now this one's a little bit different. We subtracted. So subtract 3, subtract 3, subtract 3. So what do you suppose is going to go in front of your x right here? -3. See, that's not so bad, right? You just need to remember this one, the 0 term, is your constant. That's going to go here. And then whatever you did here is going to go here. Okay? Questions on that?